Okay, so let's get started here. Well, this one here has a denominator x. Okay, so that the non-permissible value is any value of x that will make the denominator 0. So that gives us x equals to 0. Okay. This denominator 6 will never be 0. So that's where there's no non-permissible value here.
So before we do the non-permissible value, we have to multiply it or not?
No. You just look at it individually here and then there. Looking at the denominator. Yeah, you don't have to multiply. I think you're talking about lowest common denominator. Is that what you're thinking about? Okay. So what we're going to do is to solve for x. Okay, how do we do that? We're going to cross multiply. So we're going to get 18 equals to x squared minus 7x. Okay, so x squared minus 7x. We're going to end up with a quadratic equation. So when we do quadratic equation, we bring the 18 to the other side, leaving one side equal to 0. So x squared minus 7x minus 18. And now how to solve this one? Well, we can solve it by factoring or quadratic formula. Well, this one looks like it's factoring would be okay because it's not bad. Yeah, it's x minus 9 x plus 2. Okay, so we might have two possible solutions. So we have x equals to 9 and then x equals to negative 2. So what we're going to do is we're going to, verify this. The great thing is that the x's that we figured out is not one of the non-permissible value. If it's one of the non-permissible value, then the other one is already an extraneous solution. So what can we do? We're going to verify. Okay, we're going to be verifying for x equals to 9. So if x equals to 9, it's going to be, the left side is going to be 3 over 9. And then the right side would be 9 minus 7 over 6. So simplify the left side is 1/3. And then this one is going to give us 2 over 6, which is also 1/3. So that tells us that this one is a good solution, okay? Because the left side is equal to the right side. Okay? Now let's verify this one for x equals to the negative 2. Okay? So what does the left side look like? When x is negative 2, it's going to be 3 over negative 2. Okay? Or we can say negative 1/2. Negative 1.5. And then on the right side, it's going to be negative 2 minus 7 over 6. So it's going to be negative 9 over 6, which is also negative 3/2. Okay, so that one is okay as well. So that tells us that both of these, go back to these ones, both of these are solutions. Okay? Before I move forward, I wanted to show you something. Okay, I want to show you what this one looks like on Desmos, because showing this algebraically and then showing it graphically. Unfortunately, I won't be able to capture this on the this way. So is that okay now? I'll put it back. So this Desmo, so what we're going to do is I'm going to get the left side, and I'm going to make that as a function, y equals to 3 divided by x. Okay? So that's the very first one. And then the second one is y equals x minus 7 brackets divided by 6. Okay, good. So this is what the graph looks like. Okay. The red is a 3 over x, and the other one is x minus 7. What did we say the solutions are? We said that there are two solutions, and then the two solutions are the point of intersection. As you can see, the red graph and the blue graph intersect together. Okay, and then if I click on this one, okay, the point of intersection is x is -2, and we got x equals to -2 as one of our solution. And then here's the other point of intersection here. X is equals to 9. 9 is the other point of intersection, and that's 9 is our solution. Okay? So that's just showing you or giving you a visual representation of what that solving of rational equations really mean, what it looks like. Okay, so it's right here. Right. Okay, so this one here, if x is negative, if x is 9, so this one, this is going to be 9 and 1/3. So x is 9, y is 1/3. And then this one is when x equals to 2 and, minus 2, and then the y is -1.5. Okay, so that's the visual right there. Okay, so far so good. And take a look at example 2. Okay. How about this one? What can we do with this one here? Let's first state the non-permissible values. So what are the I'll put it here, non-permissible value. Yeah. So x equals 2 minus 1. Is everybody okay with this one? Yeah, the x minus 1 equals to -1 is from the x plus 1 denominator. And then what's the other one? X equals to 0. So x equals to 0. That's the one from 2x in the denominator. Okay? So those are the non-permissible value. Any ideas on how we can figure this out or solve this? Yeah, get rid of the denominator. Here's what I think this is something that's discussed in grade 11 topic. Grade 11 is what we have to do is we have to look for the lowest common denominator. Lowest common denominator. What would be the lowest common denominator for this case? Yeah, both of them, right? Is it? Then it's going to be 2x times x plus 1. Is everybody okay? Or yeah? Okay, good. And then the denominator here is 1. So what we're going to do is we're going to multiply each side of the equation by the lowest common denominator. And what it accomplishes by doing that is getting rid of the denominator. Okay, that's to eliminate the denominator. Okay, it's easier when we don't have a denominator. Okay, so what we're going to do is we're going to multiply both sides of the equation by 2x times x plus 1. Okay, so what would happen if I multiply this by 2x times x plus 1? We'll know that the 2x would cancel with this 2x, so we're left with 3 times x plus 1. Yeah, good, very good. Minus, okay, now if I take this one and multiply it with 2x, the LCD, what would we get? 2x times, okay, the x plus 1 will cancel this x plus 1. Yeah? Is everybody okay? It would be 2x. 2x times 2x equals. Now, what would happen if I take negative 2 and multiply it by LCD? Yeah, so 2x times 2x times x plus 1. Okay, is there anything in here that you're not sure of? I think now is a good time to ask where that came from. Everyone's okay? Yeah? Okay, good. So, like what we said, by multiplying each side of the equation by the LCD, we've totally eliminated the denominator, which is great. Now, we have just this one. So, let's expand it first and then organize it, right? So 3 times x plus 1 would be 3x plus 3. And then this one here, negative 2x times 2x, that's going to give us negative 4x squared equals, okay, so this is going to be 4x squared. 4x squared, okay, and then 2x, that's going to give us plus 4x. Oh yes, it is negative 2. Thank you for telling me. Okay, otherwise I would have got the wrong number. So it's going to be negative, yeah, because I didn't put the negative. So this is a negative, and then this is a negative 2. Negative as well. Okay, good. Okay, so that one looks like, what can we do? Looks like we might have a quadratic equation.
Minus, what about the
Minus
minus?
2.
For the,
Oh, it hit this one?
yeah, this one times by minus. Okay.
Yeah, it's okay? Yeah. Now I got negative 4x squared and then negative 4x squared on both sides of the equation, one side and then the other side. If I bring this to the other side, it will be canceling. So they're going to be canceled, so that's great. And then it looks like we're only left with 3x plus 3 equals to negative 4x. And then I bring all the x's. Looks like it's just going to be a linear equation. So 3x plus 4x equals to negative 3. So 7x equals to negative 3. Therefore, x is equals to negative 3 over 7. So the answer is negative 3 over 7. Okay, and then this answer is not one of the non-permissible values, so it should be okay. Okay, was that good? Yeah? So it kind of reminds us about grade 11 topic. Let's take a look at the example 3. Okay, good. Let's state the non-permissible values. Before we do that, you see this part in here? It's 2x minus 2. What we can do is we can factor that out to make it. So x over x minus 1 minus 2x equals to x plus 1 over 2 times x minus 1. What's the non-permissible value? Okay. X minus 1 can't be equal to 0, so that means x equals to positive 1. Okay, good. So that's a non-permissible value. So what we're going to do is we're going to figure out the... Yeah, exactly. Yeah, even if we don't factor and then you try to solve this, it's still going to be the same. Correct. Okay, very good. So lowest common denominator. What's the lowest common denominator in this case? Yeah, 2 times x minus 1. I'm going to leave it like that because once we multiply it in, we know which factors cancel and which factor stays. So if I do that, if I take the LCD and multiply it by the first part here, we know that the x minus 1 will get canceled out. So we're left with just a 2 and then the x. So that's 2x minus, okay, so this is over 1. When I multiply that, that's going to give us negative 2x times 2 times x minus 1. It's supposed to be 2. Okay, so far so good? No? Oh, okay. Yes, tell me when it's no, because it's better to figure that out now. So what we need to do is we're going to multiply each term, basically, each part of this by 2 times x minus 1. So if the denominator here is 1, I'm just going to do it on a separate sheet of paper. So if I go negative 2x, and if I multiply it by the LCD, which is 2 times x minus 1, nothing cancels in the denominator. So we're left with negative 2x times 2 times x minus 1. Nothing cancels. And then let's try this one. X over x minus 1. And if I multiply that with 2 times x minus 1, x minus 1s are common. We can cancel that out. So we're left with just 2 times x, which is that 2x there. Is that better or still? Okay. The last one equals to, what does it equal to? So if I take this and multiply by LCD, what's going to be happening? Well, this one will cancel all of that. And then we're just left with x plus 1. Yeah? Okay. Everyone okay? Yeah, please stop me if you don't agree with me. Okay, so let's clean this thing up. I'm going to get 2x minus, this is going to be 4x times x is going to be negative 4x squared. And then this is 4x times, or negative 4x times negative 1 is a positive 4x equals to x plus 1. Okay. Now I see that the x squares are not going to eventually cancel. I'm going to probably end up with a quadratic equation. Not probably, will. So bring everything on one side of the equation. One side equals to 0. So it's going to be 4x squared. And if I get this x, and then these 2x and 4x will give me a 6x, but if I bring it to the other side, it's going to be -6, and then plus that is minus 5x. Okay, I hope you know what I'm talking about. Yeah? You okay? And then I got the 1 at the end. Now let's see, is this factorable? Okay, so here 4 and 1, that's 4 times 1 is going to be 4. Positive 4. What are the factors of 4? That's going to give us a -5. It's going to be -4, -1. So that's going to be, okay, so that's 4x squared minus 5x plus 1 will become 4x squared minus 4x minus x plus 1. Factor by grouping. So common factor is 4x, so it's going to be x minus 1. Common factor here is -1, so it's x minus 1. X minus 1 are common factor between those two. Factor those out, and then 4x minus 1. So the factored form of that is x minus 1 times 4x minus 1. So what's our solution? Solution is x is equal to 1, and then the other one is x is equals to 1/4. Is everybody okay with 1/4? Yeah, you're probably solving that mental math in your mind. Okay. So it looks like we might have two solutions, but then let's see if there's a contradiction. So x equals to 1 is our solution, but then when we come up here, well, x cannot be 1. So this one here is our extraneous solution. Okay, so the only solution is x equals to 1/4. Yeah? That's why it's kind of nice to figure out the non-permissible right away, so that we can say cross out the ones that don't work for us. Is that okay? So far so good? You still okay? Yeah? Like I said, it looks like grade 11 stuff, because it is grade 11 stuff. Okay. Let's see this one. Let's factor out the denominator first, because that's going to make our life easy figuring out the non-permissible values. Okay. So it's going to be x minus 1 over x equals 1 over x minus 1 minus 1 over, okay, common factor is x, so x times x minus 1. Okay, x, you factor out the common factor x, so it's going to be x minus 1. Okay, non-permissible values. So what are the non-permissible values? Exactly, x equals to 0 and x equals to 1. Yeah, we got two non-permissible values. Okay, now we're gonna multiply by lowest common denominator. And what's the lowest common denominator here? Yeah, x times x minus 1. Perfect, you got it. Okay, so what we're gonna do is we're gonna multiply each part with the lowest common denominator. So let's do that. If I take this x minus 1 over x and multiply with the LCD, the x would cancel, and then we have x minus 1 times x minus 1. So let's just write that down. Okay, equals. Now if I take this part here, 1 over x minus 1, and then I multiply it with the LCD, the x minus 1 cancels, that cancels that, and then we're left with 1 times x, which is x. okay, minus, okay, now this one looks like everything's gonna cancel, right? If I take that part, multiply with everything on the LCD, everything cancels, we're left with just the 1. Yeah? Let's expand this one. So x squared minus 2x plus 1 equals x minus 1. Right? X times x is x squared minus x, and another minus x, so that's minus 2x, and then negative 1 times negative 1 is positive 1. Okay, it looks like we're going to end up with a quadratic equation again. So bring everything to one side of the equation. I'm going to just take this and bring it over there. So x squared. And if I take this x and I bring it to the other side, I'm going to get a negative 3x. That's 3x. And if I take this negative 1 and I bring it to the other side, I'm going to have a positive 1, and then add it to the 1, I'm going to get a positive 2. That's equal to 0. Okay, so is this factorable? Any factors of 2 that would add up to negative 3? Yeah, because we're going to get a negative 2 and a negative 1. So that one's not bad. X minus 2, x minus 1. Okay, so what are our solution? X is equals to 2, and x equals to 1. Good. Now, any contradiction? Yeah, you see contradiction in here. It says this is our solution, but then if we come back up here, x can't be 1. So this one is contradicting. So this one is our extraneous solution. So it looks like our solution is just the 2. How do you like that? Is that okay? Yeah, kind of takes us back to grade 11 stuff, the easy stuff. Okay, so you're gonna definitely see something like that on the test, so make sure that you're familiar with it. Okay, that concludes our lesson for today.